Okay, this is Mr. Precella back after our little break. We are working on some financial math problems. This is the review sheet from my face-to-face Math 1324 class, and this is the final review sheet for, So this is problem number 16 that we're up to. We're working with our financial formulas. We have periodic compound amount and then the annuity formulas. When I'm deciding which formula to use, I always ask, is there a series of equal periodic payments? That's what decides if it's an annuity. So number 16, a small company borrows $86,000 at 6% compounded monthly. The loan is due in 9 years. How much interest will the company pay? Well, this is a typical small business loan in that it's not like a car loan or a house loan where you're making a series of payments. On a typical small business loan, the company borrows some money, and at the end of the time here, 9 years, it says the loan is due in 9 years. At the end of the time, they're going to pay back everything, the $86,000 plus the interest. Well, this is 6% compounded monthly. Let me see. Is this an annuity? Answer is no. Okay, it's not an annuity because it's not, the company doesn't make a series of monthly payments. The way these loans work, when it says the loan is due in 9 years, that means in 9 years' time they've got to pay everything back. So this is a periodic compound amount formula. So A equals P times 1 plus I to the n. Well, P, that's the present value. A is not the total interest, or not just the interest. It's this whole future value. It'll be the $86,000 plus the interest. So we're going to need to subtract $86,000, but I'm getting ahead of myself. Let's see. P is 86,000. I is that interest rate per period. 6% compounded monthly. That would be 0.06 divided by 12.005. So 6% compounded monthly is like 0.5% each month. That's the interest rate per period. To get in, we normally multiply monthly for 9 years. How many months are there in 9 years? Well, 12 times 9 is 108. So we have A equals P times 1 plus I. Let's just go ahead and do that in our head. The 1 plus I is 1.005 to the n power. Now keep in mind, this isn't going to be the answer to the question. This is how much money the company pays back at the end of the 9 years. Let me see. 86,000 times 1.005 raised to the 108 power. So at the end of the 9 years, they're going to have to pay back $147,378 and what do y'all call that? 16 cents? But that's not the amount of interest. To get the amount of interest, we have to subtract 86,000. So the amount of interest is $61,378.16. So $61,378.16. It's another B right there. Okay. Now, problem number 17. At the end of every 3 months, a young man deposits $100 into an account that pays 5% compounded quarterly. After 4 years, he puts the accumulated amount into a certificate of deposit paying 7.5% compounded semi-annually for 1 year. When this certificate matures, how much will he have accumulated? Well, this is going to be a 2-step problem here. First step, at the end of every 3 months, this man deposits $100 into an account that pays 5% compounded quarterly. So he's putting this money in quarterly. It says at the end of every 3 months. So he's depositing $100 quarterly. Then, after 4 years, so this first part of the timeline is 4 years. So he's doing this for 4 years. Then after 4 years, he puts the accumulated amount into a certificate of deposit that pays 7.5% semi-annually for just 1 year. How much will he have accumulated when the certificate matures? With the certificate of deposit, there's no monthly payments. You just put the money in there and leave it. There. The motion detector didn't detect any motion, so they cut every lights off. So there's nothing wrong with your computer. So let's look at this first part. Is this an annuity? The person's saving $100 every 3 months. So yes, this is a annuity because there's equal periodic payments, $100 every 3 months. Move this up so y'all can see it a little better. Then, well, what are we trying to find on this part of the timeline? Do we need to know the present value or the future value? Well, we're assuming when he starts this, opens this account and starts saving, that the present value in here is 0. It better be 0. If there were $1 million or something in that account that we didn't know about, we of course couldn't answer the problem. So we're assuming that he opened the account and there was $0. So what we want to know is this future value here. So we need to know the future value of an ordinary annuity. We know it's ordinary because it says end. So future value of an ordinary annuity, S equals R times 1 plus I to the n minus 1 all over I. S would be this amount right here, future value. R is the payment or the deposit, $100. I is that interest rate per period. Well, 5% quarterly, 0.05 divided by 4 is 0.0125. So it's like 12.5% each quarter. Adds up, 5 of those add up to 5%. Excuse me, 4 of those add up to 5%. N is the total number of periods. Well, how many quarterly periods are there in 4 years? Well, there's 4 quarters per year for 4 years, so N is 16. So we have S equals R times 1 plus I let me move it up to the N minus 1 all over I. That's going to tell us how much those $100 deposits accumulate to. Okay. So, get my calculator. Ooh. So, 1.0125 raised to the 16th power, subtract 1, hit enter, divided by 0.0125, enter, times 100. So his little quarterly deposits grew to $1,759 and, how would y'all round that, 12 cents? That's how much money is in the account after the 4 years. He's saving $100 every 3 months. Oh, there. And so at the end of the 4 years, he's not going to be rich or anything. $1,759.12. This motion detector is going crazy in this room. So that's how much is right there. Now, for the second part of the timeline, this is no longer an annuity. The person is just letting the money sit there. Oops. Where are we? Sit in the CD for 1 year. There's no longer any payments. With the certificate of deposit, you put one lump sum in and then just leave it there. So this is a periodic compound amount formula. A equals P times 1 plus I to the N. Notice that for this line right here, this part of the timeline, this future value is now the present value. So P is 1759.12. I, you divide 7.5% semi-annually. That would be 0.075 divided by 2. So 0.0375. Did I do that right? What's 0.075 divided by 2? Yeah, 0.0375. To get N, we multiply, well, how many semi-annual periods are there in 1 year? Well, there's 2 semi-annual periods. So A equals P, and this 1 plus I, I'm going to go ahead and just do that in my head, 1.0375, the second power, or squared. So punching this into my calculator, you know what I'm going to do? I'm going to do the lazy man's. Oh, no, here, there it is. Let me, let's say clear. Let me bring this down a little. Okay, so it's 1759.12 times 1.0375 squared. So we're getting 1893.53. depending on how they rounded this answer, we might be 1 or 2 cents off here. Let's see, what are we going to have? 1893.52. I think the software didn't round this to 12 cents. They left it 0.11 whatever, okay? But theoretically, it should have been rounded. Not theoretically, in practical uses, it would have been rounded to 12 cents. So 53 cents is the more correct answer. But we choose the closest answer, so C. Okay? A little bit of round off error there. And that's number 17. Let me see if I can arrange it right there. There we go. All see that? Okay, good. Now, let's do this last problem today. Do one more. Last problem on this page, number 18. A lady wants to start an IRA that will have $570,000 in it when she retires in 20 years. How much should she invest semi-annually in her IRA to do this if the interest is 15% compounded semi-annually? Well, the $570,000, that's how much she wants to have in the account at the end of the 20 years. So that's a future value. The interest rate is 15% semi-annual, compounded semi-annually. A lady wants to start an IRA that will have $570,000 in it when she retires in 20 years. How much should she invest semi-annually? Well, is this an annuity? Is there going to be a series of equal periodic payments into this account? Well, yes. She's not just going to make one lump sum. How much should she invest semi-annually? So every 6 months, she's going to be putting money into that account. This is an annuity. Well, of our annuity formulas, is this a present value or a future value problem? Well, that $570,000 is a future value. So it's either future value of ordinary annuity or future value of an annuity. At no time does it ever say annuity due or the word beginning, so it's an ordinary annuity. Okay? So we're looking at future value ordinary annuity. S equals R times 1 plus I to the n minus 1 all over I. R is the payments. That's what we want to know. S, that future value, is $570,000. To get I, we divide. 15% semi-annual, that would be like 7.5% each 6 months. So 0.15 divided by 2 is 0.075. Now what about N? How many periods are we looking at? How many semi-annual periods are there in 20 years? Well, there's two semi-annual periods per year. For 20 years, that would be 40 semi-annual periods. So now S equals, not S, we know S, 570,000 equals R times 1 plus I, that would be 1.075 to the N, minus 1 all over I. Get my little calculator out. And punching in 1.075 raised to the 40th power, and then subtract 1. Now divided by 0.075. Enter. And what am I going to do to get the r by, or to solve for r? Am I going to multiply now or divide? There with the lights blinking again. Again, nothing wrong with your computer. So 570,000, we divide. 570,000 divided by that 227 point. So how much should she be depositing semi-annually? Well, $2,508 and what is that? 18 cents. Let me see. Where's the problem? $2,508.18 is how much money she would need to deposit semi-annually in order to get that $570,000 in her account in 20 years' time. Okay? Any questions there? Let me see. Let me put the whole problem up. This is number 18. There it is. Just like that. There's the whole problem. Worked out. Nice and neatly. Well, I don't know about neatly. Okay. Well, thanks for watching or listening. And I'll be seeing you soon. Hopefully, maybe. Thanks again. Bye-bye.